All right, welcome to Chapter 1 lecture, The Tools of Geography. We're going to go ahead and just jump right in. All right, so just a quick introduction. I'm going to talk about two main areas of geography study. Okay, so there's the study of physical geography and human geography. Physical geography is the study of natural features on the surface of the earth, such as landforms, mountains, plants, animals. Also, things that aren't necessarily physically you're able to see, but scientific things like the turn of the earth, why we have weather patterns, why we have seasons, why we have temperature and wind. More scientific based type things. Human geography is a little bit less scientific, but it also is very important. And it's the way people spread across the earth and interact with the earth and each other. So it's answering questions like who lives where, how, and why. Talk about human-made features like towns, farms, dams, and roads. All right, the geographic inquiry process, your book goes into this in a little bit more detail, so I'm not going to dwell on it too much. But basically, when we have a geographic-related question, we acquire geographic information by either going somewhere, looking at a map, or talking to people who have been there. We organize that geographic information, and in general, the way that a lot of geographic information is organized is on a map, which is what we're going to mostly talk about here in this lecture. Then we analyze that information to come up with an answer. And again, reading in your book will give you a little more information. Here's a few terms for you: absolute location, distortion, map projection, and relative location. A little bit about the difference between absolute and relative location. Think about your address, your actual mailing address would be your absolute location. No matter where I am on the earth, if you give me your address, I'm able to mail something to you or find your address. Relative location would be you explaining how to get to your home without giving me your address, like saying, oh, go 2 blocks left and then turn and go east. That's relative location because you know where I am and you're helping to talk me through where you are in relation to where I am. Distortion and map projection are kind of similar things. So down here you can see this is a map projection of this, which is the actual spherical globe. Okay, whenever you make a map projection, you distort the image. This is round, this is not round. So we are changing the shape or size of something on that map by flattening it out. And you can see a little bit more stark reality to this when you look at this kind of horrifying picture here of this person. And now look how distorted his face is. So that's what happens whenever you look at a flat map. There's some kind of distortion going on. All right, a couple of things you need to know about maps. So maps all have titles. This one is talking about the political boundaries of the world. Notice that this map is upside down, at least by our Northern Hemisphere standards. This is upside down. This is a perfectly acceptable map. This is just as valid a way to look at the world as any other way. But to us, it's upside down. South is pointing up and north is pointing down. This is the political boundaries of the world. So it's showing the different imaginary lines that make up countries. All right. Then we have a compass rose. Okay. So this compass rose has north pointing this way, south pointing this way. This compass rose is reversed. Whoops, excuse me. This compass rose just shows the cardinal directions. Cardinal directions are north, east, south, and west. Never eat soggy waffles. This map shows the cardinal directions, but it also shows smaller little lines here in between. These are called intermediate directions. So if I'm going on a diagonal here, I'm going southwest. Between north and west is northwest, north and east is northeast, south and east is southeast. All right. A lot of maps also have a map legend or a map key, which is just a little square that will usually help you interpret some of the lines or symbols that you see on a map so you know what they mean. Map grids or global grids help you find places on a map. So this global grid or this map grid right here, if I say it's kind of like a game of Battleship. If I say the miner's cabin is E5 on your map, and you open your map up, you find E and you find 5 and you find where they intersect, you're going to see the miner's cabin right there. Global grid has that as well, although we call them lines of latitude and longitude, which I'm going to go into more detail right now. All right, we actually call those coordinates when we're talking about the globe. Okay, so as you can see right here, these are coordinates. So if I told you a certain degree latitude and certain degree longitude, you could find the absolute location, just like an address, anywhere on the earth. All right, so parallels of latitude are imaginary lines that run east and west along the earth. Okay, the equator is obviously that biggest middle line there. And then these other lines are just called parallels of latitude. I remember latitude because it looks like the rungs of a ladder. I could climb up those because they're running horizontal, not vertical. Okay, so you just go a certain amount of degrees to the north or a certain amount of degrees to the south to be able to give someone your degrees of latitude. So if I'm in somewhere in Central America here, I say I'm 15 degrees north of the equator. Anyone looking for me would know this somewhere along this line on Earth is where I am. Now they've narrowed it down. They don't have to be looking down here or up here for me. Okay. Obviously, the equator is that important line that runs through the middle. Going vertical, north and south, are called meridians of longitude. And I think longitude because they're very long lines, they go up and down. The middle line is called the prime meridian when it's running through Europe. The opposite side of the Earth, when it's running through the Pacific Ocean, it's called the international date line. And I'll show you that in a moment, why that is. But same concept here. I go a certain amount of degrees east from the prime meridian or a certain amount of degrees west. So if I told you I was at 15 degrees north, and then I said that I am 30 degrees west of the prime meridian, so 30 degrees west, 15 degrees north, you would be able to zero in on my almost exact location on the Earth. All right. So let me just show you really quickly. I'll exit the lecture for a moment and just show you. So the equator is the line running along the Earth this way. Okay. And it's called the prime meridian when it's running, I'll zoom out a little bit, when it's running from the North Pole to the South Pole on this side of the Earth. But then it also runs from the North Pole to the South Pole on this side of the Earth, or the Pacific Ocean. Okay, we call it the international date line because basically we're starting, when we're talking about time zones, the first time zone is right here in England, because they kind of were the powerful country at the time that we set up standardized time. So this first time zone is in England, and then it just goes all the time zones from there to the end of the day, and the day ends here at the international date line. Once you cross the international date line, it is actually a different date, so the times actually change. It's a little bit confusing to talk about, but it obviously has to do with what we're going to talk about later, the rotation of the Earth. As you can see here, as I turn this globe, parts of the globe are in the sunlight, meaning it's daytime for this part of the globe, and the other half of the globe is in the shadow, meaning the sunlight's not reaching it, so it's nighttime. The Earth rotates, and because it rotates, we have sunrises and sunsets. As we rotate nearer the sun, it looks like the sun is rising in the sky and moving across the sky, but we're actually the one that's moving. And then as it rotates away and starts to go into this shadow here, that's our sunset. Okay. All right, we'll touch on that topic again in a second. But first, let's talk about distances. So when we're talking about distances, basically we're shrinking a real-life version of the world into a smaller model. And so we have to tell the scale of that model. Okay, so maybe 1 or 2 inches on your map represents several miles, 10 or even 100 miles in real life. Okay, so that's what these map scales are telling you here. And I could use a scale strip to know for sure the distance. So if I wanted to calculate the distance between Washington, D.C. and Arlington, I could take a piece of paper or a string or a ruler, line it up with my map scale, mark it in some way, then take that string or ruler or extra piece of paper, line it up between my 2 distances, and then compare those distances. And then I could say, oh, okay, it's this many miles between Washington and Arlington. All right, so this is some imaginary ways of talking about the Earth. When we're talking about the northern top half of the world, we're talking about a hemisphere called the Northern Hemisphere. Under the equator or south of the equator, we're calling it the Southern Hemisphere. We can also divide it again along the prime meridian / international date line and call it the Western Hemisphere or the Eastern Hemisphere. Hemi meaning half, sphere meaning ball, circle, so hemisphere. We also can divide it into smaller regions, continents. Okay, so we got North America, South America, Europe, Asia, Africa, and Australia are the 7 continents. Europe and Asia are actually one landmass, but because they're so different culturally and historically, we actually are going to call them 2 different continents. All right. We also have 4 oceans: the Pacific, Atlantic, Arctic, and Indian. It looks like 5 on this map because the Pacific is so large. Okay. But actually, so that's what I learned. I learned there were 4 oceans when I was growing up. But actually, nowadays, we like to say there's 5 oceans because we either sometimes call this the Southern Ocean, sometimes call it the Antarctic Ocean. So that's the 5th ocean is down here around Antarctica. Okay, I talked about this, how a rotation is a day and how the sunlight touches. Whatever the sunlight touches is its daytime. Whatever's in shadow is nighttime. And as we rotate, we change time zone. We change the time. The Earth also revolves, and as the Earth revolves, it moves. So not only is it spinning, but it's also moving around the sun, and that's what makes up a year. One trip around the sun is a year. Okay. We also have this thing called the tilt of the axis. So this is an imaginary line running through the very middle of the Earth, and it tilts. So as the Earth is this way, the northern hemisphere is a little closer to the sun, and so our days are longer. That's summer. The southern hemisphere is in their winter time because they're tilted a little bit further away from the sun. They have shorter days and cooler temperatures. Then, and as it becomes our winter, we tilt away in the north from the sun, and the south here tilts towards the sun. So this graphic you can see here, the northern hemisphere is experiencing winter, and the southern hemisphere is experiencing summer. We also have these zones. Okay, so from the equator to the Tropic of Cancer, which is this other imaginary parallel line, and the Tropic of Capricorn, everything in between here is called a tropical zone because it tends to be closer to the sun, gets more sunlight, it's just warmer weather. The Arctic circles are down here. They tend to get less sunlight, and so they are polar zones, the Arctic Circle and the Antarctic Circle. Okay, they are polar zones. They are cold all the time. Everything in between in the Arctic zones, or the polar zones, and the tropical zones are called temperate zones. They're in between, sometimes warmer, sometimes cooler. And then finally, we're just talking about section 8 is just showing how to show a round world on a flat map. We've talked about map projections before. So these are map projections. These are all different types of projections, and they all distort the world in a different way. Okay, so this shows kind of that round shape, but it's going to distort some of the distances. It's certainly going to distort, since the Earth is round, it's not showing, that these two parts of the Earth are connected. Okay, this doesn't distort distances or shape, but it blocks us from seeing the whole southern hemisphere. And we really can't see a lot of countries as well as we would like to see. Okay, this map of the world shows us everything we want to see. Oh, by the way, this distorted the shape of Antarctica really badly, and a lot of maps will do that. This shows us everything we want to see, but is going to distort some of the shapes because it's flat. This won't distort shapes, but it will distort distances because, as you can see, we've had to make these weird shapes out of the map. And so it's really hard to calculate the distance from here to here. Even though there's really no distance at all, it looks like there's a ton of distance. If I were to cut this out and make it and fold it up on itself, it would look like a globe, and then it would be a little bit more accurate. But just understand that every map you're going to see is slightly different projection depending on what the geographer is wanting to show to you. They're going to pick what map, what projection, what strengths that projection has, because the weaknesses don't matter as much to them depending on what kind of information they want to show you. So I hope that was helpful, and we will see you next time.